So I've been working on IDKLOL, which is my 3D ECS-based RPG. First, I built a road straight across town at a random Z coordinate, and added a gate on either end, then surrounded the perimeter with stone walls. Then I cover the remaining area with gravel and add it to the available tiles. For each building, I generate a rectangle at a random position and make sure it only covers the available tiles so it's not overlapping with the other buildings or the road. Then I added a doorway at a random position along the front of each building, which is the side that's facing the main road. From there, I found the closest road tile to the doorway and used A* to connect all of the doorways to the main road. And the town is procedurally generated, so the buildings and roads will be in different positions each time you make a new game, as you can see. Right now, it looks a lot like Minecraft, since it's mostly block-based, except for the roofs and trees. That's because the original tutorial is on a 2D top-down grid, and I only have one layer of blocks to work with. Eventually, I will make the terrain and buildings more realistic. And you can go inside the buildings, but I haven't added the doorway or furniture yet, so it's just the walls and floor for now. In the original Rusty roguelike, there are tables and chairs in the buildings, with NPCs wandering around. Each building is designated as a tavern, alchemist shop, house, etc., and some of them have special vendors that sell specific items. I will be adding NPCs to the 3D version, but I'm still looking for a good model. I did find the Make Human program, which is open source and Creative Commons, but I believe they only have set poses, so I'd still have to do something about the animations. So in the 3D version, I have a csgbox 3D for the wall, floor, and ground meshes. And I can drag a material resource into the material to change the texture from grass to gravel, for example. Then when I render the map builder, I assign the tile type to a renderable and optionally add the material 3D. The renderable and material 3D classes have an enumerator with all of the types and a constant dictionary which maps the type index to the sine, which is preloaded, which makes it more efficient, and you don't have to store the whole string in memory, you can just store the index. Then I use a static function to return the sine instance or the material, depending. And because this is static and constant, you can call the class from anywhere without making a new instance like it's a global resource. Then in the render system, I assign the node to the renderable new scene, and if the entity has the material component, I assign the mesh.material equal to the getMaterial. To make a new material, add add a new resource and find the standard 3D material and save the resource. Then drag the base image into the albedo property in the texture, and you can add the other modifiers like the roughness into the roughness property texture to add more detail. You can download these textures from ambientcg.com. There's a bunch of different ground, rock, metal, and wood textures here that are free for commercial use and Creative Commons. They come with a zip file with all of the different layers as well. And for the roofs, I have a generic triangle with two planes on top made from the CG meshes. And then I set the scale component in the render function, so you can stretch the roof to whatever size of the building that you need. On the west side of town, I have a shoreline generated from a sine curve, then staggered by random amounts to create a more jagged edge. And I added some piers at random lengths and increments as well. So I added some deep and shallow water here. Currently it's just a semi-transparent mesh, and I turned off the collision so you can fall in the water, but I'm not sure how to set up the gravity with the kinematic body so you can actually swim. So I'll have to figure that out at some point. And on the east side of town, the road winds through a heavily wooded forest. As you can see, there are clearings off the road between the trees that you can explore, and later I'll spawn some wolves and bandits in these areas. And the game does lag when I'm recording, even though I have the preview turned off, but if you download it from the GitHub, it runs much smoother. So the trees are still spawned on a grid, but I randomized the rotation and scale so they look more natural. And the road leads to the other end of the map, where I'll place the dungeon at some point in the future. The forest map uses a cellular automata algorithm to generate random walls and floor. Then it counts the surrounding neighbors to make clusters of the floors and walls. You may be familiar with this from Conway's Game of Life, which makes the cells live or die depending on the neighbors. Then to build the path through the forest, the roguelike tutorial uses the Dijkstra map algorithm, which calculates the distance to the exit. However, Godot doesn't have this built in, so I just used A* for this. I got the tree model from quaternius.com. He has a bunch of different assets So I got the stylized tree pack, which has oak and birch textures. So these are free for commercial use, but you can donate to his Patreon as well. Then you may have noticed I added a mini map in the bottom right corner, which shows a top-down view of the map. To achieve this, I have a panel container in the main sub-viewport. This allows me to add the black border around the mini-map. Then I have a second sub-viewport container with a sub-viewport and a camera 3D under that. This is pointing downwards, and I have the projection to orthogonal, so the right angles are squared off instead of getting distorted from the distance. Then I have a remote transform 3D node centered above the player entity. And when the player is rendered, it updates the camera, which gets the path to the minimap from the player and sets the minimap transform remote path from that to update the camera so it follows the player around. Then I got the player character from opengameart.org. This is the Adventure Militia Peasant Low Poly model, and it comes with a variety of weapons. So this site is more of an aggregate, and not all the models are for commercial use, so you'll want to check the attribution license before you use it. And this model does come rigged with an idle and attack animation. So he swings his sword and looks around, but I haven't mapped those in the game yet. So the clothes are part of the actual mesh. They aren't separated from the body, which means I can't really change the gear without editing the model, which is why I need to go and get a different model from somewhere else. So next time I'll be procedurally generating the buildings using the CSG subtraction mode. But that's all for this episode of IDKLOL. So thank you for watching and have a great day.